Hey guys, welcome back to the channel. All right, so as I promised in my previous video, I wanted to go a little bit more in depth, or actually very in depth, on the new Atlas screen mount. So first off, if you're new to the channel, welcome. My name is Matt. This is Tech Forum. On this channel, I primarily discuss the ownership experience of a very early VIN Tesla Model 3. I've got about 110,000 miles on my car. But this video in particular has to do with an invention of mine. This I'm calling the Atlas mount. It allows you to swivel the screen on the Model 3 or Model Y left and right, as well as pitch adjust it down or up. And so today I wanted to discuss the specifics of this mount. So right off the bat, some of this will be a little bit technical and a bit nerdy, so I apologize for that. But this is for those that really want to know what I've gone through in designing this. So the top portion of it is essentially the same as the top portion of my standard left-right swiveling kit. So a lot of that may sound familiar from my technical deep dive on this screen mount. But as we get to the bottom, you'll notice differences because that's all new. So most of the mount is 6061 T6 aircraft aluminum, except for the pivot. The pivot is actually 7075 aluminum. That was done for a variety of reasons. One was durability, strength. Number two, machinability, the tap threads and that. Number three is the coefficient of friction between the material and the bearings that it pivots in. And number four, though 7075 is more expensive than 6061, at least at the time of our designing this, it was easier to get round bar stock in 7075. But again, it actually works better, being that we are pivoting aluminum inside of a plastic bearing under tension. And so the plastic does, or the aluminum does have a tendency to gall or shed microscopic particles of itself into the plastic. Now, and 7075 tends to not do that. Now, the upper pivot here is a different polymer than the bearing material for the lower pivot. And so this polymer doesn't tend to drag molecular material off of the aluminum and impregnate itself on the surface with the aluminum. But this nylon-based polymer, that's nylon-based material that's used for the pitch angle pivot, would tend to drag aluminum material off of 6061, but it tends to not do that with 7075. So that was critical. Underneath this stud is a Belleville spring, and beneath that is a thrust bearing, which is a shim or a washer, the ball bearing itself, and then another shim underneath that. That Belleville spring is critical because as expansion and contraction with temperature occurs and a little bit of wear of this polymer washer, it keeps a consistent amount of tension on that pivot for a consistent amount of friction when you're swiveling the screen left and right. So that was very critical. This pivot it's not just a threaded rod, it's actually what they call a setup stud. The thread is slightly different. It lends itself better to this application than a simple double-side threaded stud would. Now moving down, also this C-shaped component here is actually longer than it used to be. In fact, I've got one of the original pivoting screen mount kits here, and if you look, you'll notice that if you line up these mount holes here, this section isn't needed, but if you line up these mount holes, you'll notice that this detail here is moved a ½ inch, or roughly 12 millimeters, further away from the dash than on this mount. And I did that initially as an upgrade to this swiveling screen mount to move the screen slightly away from the dash. But it was originally done for this mount for a couple of reasons. not the least of which was to provide additional clearance for these large sections here to allow it to swivel further. But it also is beneficial because it moves the screen slightly closer to your hand. One other aspect of this, if you look down this center line here, the center line of this pivot and where this stud is, the pivot is offset about 1/4 of an inch, 6.5 millimeters further from the stud. So this mount steps the screen another 6 millimeters or 1/4 of an inch closer to your hand, even beyond this updated moved swiveling kit. And that was important. Again, when you look at it from the side, you can see that this is offset as you go up to the stud there. Critical item. Now, when you get to the pitch angle adjustment or pitch angle section of this, all the components, again, we've got the 70-75 pivot inside the 60-61 framework here, but there is a bearing inside there, and that's pretty similar to like the main bearing in an automotive application between the crankshaft and the case. And on the inside here, you'll notice that that bearing is flanged, and so the bearings are inserted from the inside. Then the pivot is put through, and when this strain relief for the wire harness is installed, that captures the bearings in place, so they cannot fall out. I didn't want to have to use any adhesive on those bearings to hold them in place. They also are keyed into these notches here. Inside there's a nub that is molded into these bearings, so they're keyed into this housing. So the shaft, the pivot shaft here, rotates inside the bearing rather than the bearing wanting to turn inside the housing. That was very, very important, because if the bearing starts turning inside the housing, it changes the characteristics of that pitch adjustment. It makes it a little bit tighter, and it feels unusual. So we needed to make sure that the bearing was keyed in, so it could not move with the clamp itself, but rather the shaft would turn inside the bearing. These two screws they allow tension to be added to or removed from that bearing. So let's say you want to make the screen pivot. Right now I have this one set real stiff. If you want it to pivot more easily, you could just back the screw off 1/8 of a turn. I will include an Allen wrench with each kit to accomplish that. These screws are very fine thread. They are 1/4 28, which is very similar to 6 millimeter by 1 millimeter thread pitch. That fine thread is done so that when you're adjusting these screws, you can get a much better resolution. A given amount of screw rotation is less clamping movement. It makes it easier to get just the right amount of tension on each pivoting bearing. Also, the threaded stud, that is inserted into the base with a special tool that inserts it with a very high degree of pressure, and it's red Loctited in place, so the stud cannot back out of the base. If you make any adjustments or want to remove this nut, the stud will stay in place. It was kind of important. Initially, I was just threading them in, wasn't thinking much about it, but the stud would come out of the base on the original mounts, the original swiveling screen mount kits from a year back. So that is now, it's threaded in a tapered manner, so that stud threads in very, very tight. I had to make a special tool to grab the stud strong enough that we could get that stud threaded in all the way, and then again, it is also red Loctited in place. You'll notice these felt bumpers. Those are bottoming stops. I'll show you on the back of my model here, my demo model. So these stops are here, and as the screen swivels over, it bumps into those stops. So that was very critical to protect the screen, but just to give it a soft bottoming out area. And when it's bottomed out, you can still change the pitch angle, because the back of the screen is curved in that area. So it bumps into those felt stops. This new, the Atlas screen mount versus the original swiveling screen mount, has an even greater degree of left-right pitch adjustment or angle swivel adjustment, and the total pitch angle adjustment is crazy. I mean, it's far further than you would ever need. I mean, look at that. Far more than you could ever need. Also, as I mentioned earlier, this strain relief, that's a 3D printed part. What that is designed to do is to take, to alleviate the strain off of the connector. On the back of the screen, the wire that plugs into the screen has a plastic connector on it. And with the Chinese kits, if you swivel it left and right, the wire harness is putting a left and right torque moment onto that connector. So the screen circuit board is right about here in distance away from there. You've got the connector, and then the wire harness is right there. So I have the strain relief that grabs the wire harness. So now the wire harness will just very gently flex behind the screen mount as you swivel the screen, instead of torquing back and forth on that connector right behind the screen. Very, very critical item that, again, the copy knockoff screen mounts just omit that because it's not needed to make the screen function, to make it pivot. But my goal in producing products is longevity. I want to know that this part will outlive the car and never need any service. You should never have to adjust anything unless you want to change the either swiveling or pitch tension. Then you can do that. But I don't want there to be any wear or any possibility of a problem. The mount is CNC machined out of solid billet, which is bar stock, rather than cast. Now, if I went with a casted mount, there would be the casting molds, and that would be expensive to initially set up, but it would save me a fortune on these mounts. But I went with CNC machining rather than casting, because casting will have a tendency of cracking over time. CNC machining out of solid billet is permanent. I mean, this is stronger than the screen or the metal brackets that retain the screen into the car. Now, you'll notice that this pinch clamp area is back cut. That back cutting, we're experimenting with how much depth is ideal for that, but that was critical. With the first prototypes, that wasn't back cut. And what would happen is, as I would tighten the screw down, it was very difficult to provide enough clamp wrap or movement around the shaft to make it easily adjustable. So, and I noticed that if you buy clamping collars like this through McMaster Car or any supply house, most of them come slightly back cut. So we began experimenting with back cutting it, and that allowed two things. One, again, it allows the clamp to much more easily clamp around the pivot shaft, and no, that does not weaken the part there. For one thing, if you look deep inside, it's more back cut on the sides than in the center. So there's still a lot of meat there, but also it gives us a notch with which to key that bearing into, so the bearing doesn't rotate into the housing. So it kills two birds with one stone. And now in my other video, I mentioned the difference in polymer type between the swiveling washer here versus the material that this pivot operates in. That is very, very critical. That's almost as critical as the type of pivot we have going on here, because I wanted a different amount of friction for the pitch adjustment versus the left-right pivoting action. And the way to do that isn't just with more tension on the same friction material, but a different type of friction material will give not just a different level of tension, but a different behavior, a different feel. When you pitch adjust it, you can tell, wow, that really wants to stay where you leave it. When you swivel it, it's got a much more fluid motion where you go, wow, that's nice. That wants to be swiveled left and right. And the reason that it's done that way is because in the demographic research that I did with everyone that sat in my car, they said, well, Matt, I love the idea, but basically I'd get in the car, find the pitch angle that I want, and probably never adjust it. Maybe my wife will get in the car and she'll change it where she wants it, but I want to know that I can swivel it left and right without it changing in pitch adjustment because I'm swiveling it. So you'll notice I can change the pitch angle and swivel it, and by me grabbing the screen and swiveling it, the pitch adjustment stays consistent. That was not easy to achieve. Let me tell you. Initially, it was almost like a rear view mirror in a car, where the left, right, forward, back leaning was kind of the same, and I grabbed the screen to swivel it, and it would pitch change too, and then I'm trying to get it right. I'm thinking, there's no way I can market this thing if every time the passenger swivels it one way and the driver swivels it back, if every time they do that, they have to then adjust it this way too. That would be ridiculous. And so, so that was a really critical part. Coming up with a pivot that would allow the pitch angle and still be strong, that was a rough one. There is very, very little room between the mount bosses of the screen, and I wanted to have the strain relief for the wire harness, and initially I was looking at this same type of pivot with studs, and how's that going to work, and it was complicated and high parts count and heavy and very expensive to make. So eventually I came out with this design, and I had initially handmade 4 or 5 different iterations of this, where I was taking wraparound clamps and TIG welding them to a chunk up here that I was drilling and tapping through, and then I handmade one of these stepped forward mount bases. And so I've got several handmade screen mounts with various different iterations. This part was steel on the first one. The pivot was a larger diameter on the first one. This that was another big deal. This pivot here is 3/4 of an inch in diameter. That was critical, very critical, for a bunch of reasons. Not the least of which was that was the largest diameter I could use without creating other mechanical interferences. Like, it gets close to this threaded stud there, and there was no room. I thought about going with a 1/2 inch, but this 5/16 hole that's drilled and tapped to mount the screen to, a 1/2 inch shaft would be really tiny. It would be very weak right there. And it was difficult to get enough friction for that diameter, around that diameter, to make the pitch adjustment correct with only a 1/2 inch shaft. When I went to from a 3/4 to a 7/8 larger diameter pivoting shaft, there was too much drag. So this side gave the perfect amount of friction, the right diameter, the right amount of strength, enough mechanical clearance. I mean, that was a big deal in and of itself. The machined depth of this flat, that was done for a bunch of reasons. One is for depth of threads. I wanted, you'll notice that less than half of it has been machined down. I wanted to have enough depth for threads. Also, we wanted room to be able to grab this part in the milling fixture. So you have to go beyond the center point so that it wraps around and captures the part so it doesn't skip out of the mill. That was very critical. Let's see here, what else? Screw sizes, there were just so many things. This, the 3D printing of this strain relief, I think this was 5 revisions just to get that part correct. And as I mentioned before, that part serves 2 purposes: as a strain relief for the harness, as well as capturing the bearings in place, which are inserted from the inside of these clamp surfaces. So all of those things combined, this was a monumental undertaking. I was getting a lot of orders, and I still am, for the normal swiveling screen mount kit, which, by the way, these are in production at the same time. This is not being replaced by this. It's not. This isn't being discontinued. They're two separate products. The swiveling mount versus the Atlas mount, there's an $80 difference in price, and so I found that about 50% of the people that were given the option stuck with this to save money and said, I will never pitch adjust it. So, and the other 50% of the people said, this is the way to go. My wife and I are different height. We want to change it to our liking, or I just like the option, or they wanted what's latest and greatest. And so, so both of the mounts are available separately. I'm not sure if my Shopify order page will be up for the Atlas mount yet, but I will have a link in the description below. If you want one of these Atlas mounts, you can order the standard pivoting screen mount and then send me a message through Shopify that you want to upgrade to this. And what I've been doing with that is taking the order for the standard swiveling kit and marking down, writing Atlas on the order. And the Atlas mount is $80 more, and what I'm doing is when they're ready to ship, I will email the customer to pay the $80 difference, and right before it ships. So that's the way I've been handling reservations for the Atlas mounts up to this point. But if there's an order link for the Atlas mount by the time I upload this video, then I'll put some text on the screen and I'll put a link in the description below to order it. For right now, we're probably running for new orders of these, I'm guessing 5 weeks out, maybe 6 weeks. We will catch up to the point where we'll be shipping regularly, but for right now, we had to shut down all production to tool up for this mount, and now the machinist is pumping these out like crazy. They're in production. I have a batch of them in my shop that I'm assembling now, but he also needs to produce this mount, so he's making the Atlas mount in bulk and then going back to the swiveling mount production so we can keep providing our customers with all the orders that they've placed. So I think that's where I'll end it for today. I'm sure there are going to be things that I forgot that I'm going to wish that I mentioned in this video, but rest assured, I have put an enormous amount of time and effort into this. Any upgrades that I make, I've been inventing and marketing products for many years. Any upgrade that I make has to be something that I want and that I personally use. So that's been my philosophy, is if it's not something that I want and that I would install on my car, then I don't expect my customers to be that excited about it either. So aside from that, I'm going to go ahead and give you a view of this. We'll rotate it around so you can see every angle of it, so you can know what you're getting when you order it. This one is an early production part, so you may see some machining marks in that won't be present on the mass-produced kits, because we're making changes to the machining process and that. So these are, again, the 2 tension screws that you would tighten or loosen slightly in order to change the pitch angle tension on the pivot. So again, that's it. So thanks a lot, guys. If you have any questions, by all means, leave them in the comments section below. I really do appreciate all of you. And keep your eye on the channel for more updates. I'll give production updates and that as I have them. And I have a video coming up on where is my car. My car has been at Tesla for, as of today, 2 weeks. 2 weeks to get repaired. An issue with the power steering. They have been awesome to deal with, but this is a problem that Tesla corporate has never even seen before. So I've got a video coming up on that once they figure it out. And you guys will want to keep your eye on the channel. So thanks, guys. Take it easy now. Bye-bye.